Okay. Okay, so we're going to continue with section 3.6, and we're going to continue talking about the chain rule. Now, what we did the other day, one of the examples that we did with the chain rule looked like this. I believe it was, we said that y is equal to sine of x cubed, right? And do you remember I said that any situation where you would normally see an x, if you see something other than just x, then it's probably a chain rule problem. And where you normally see an x, you see x cubed. So this is a composition function. And the way that you learned how to do this last week is you would take the inside function and say that, and set it equal to u equals x cubed, and then you would say y is equal to sine of u. Do you remember this? Yes. Okay? And then you would find the derivative here, which is du dx, which is equal to 3x squared. Then you would find the derivative here, dy du, which is cosine of u. And then I showed you how, I need a new marker. I didn't show you how I need a new marker, but I am showing you how I need a new marker. All right. There we go. And I showed you how, if you want dy dx, okay, that dy dx is equal to du dx times dy du, because the du's cancel. And so dy dx is equal to du dx times dy du. Du dx is 3x squared. Dy du is cosine of u. And u is equal to x cubed. So we can take out the u and put in an x cubed. And there's your derivative. 3x squared times cosine of x cubed. That's how we did it the other day. We're gonna now I'm going to show you the chain rule again, but I'm going to show you how to do it a little bit quicker without having to do the u, without using u substitution. That was with u substitution. When you look at a composition function, if you can interpret, if you can sort of take it apart in your brain, you can look at this and you can say, well, look, there are two functions here. One of them is the inside function, and the other one, what would I call the other one? The outside function. Oops, need an S in there. The outside function. So, we have the inside function, and then we have the outside function. And if you want the derivative, then one way of doing this is dy dx is equal to the derivative of the inside, or inside prime, times the derivative of the outside, or outside prime. When you do the derivative of the outside, though, you leave the inside unchanged. And that's the chain rule. Yeah, we'll do that one. We'll start with that one, and then we'll do a couple more. So the derivative of the inside times the derivative of the outside, but with the inside unchanged. So if we look at this one, if we want dy dx, what is the derivative of the inside function? Yeah, 3x squared. What's the derivative of the outside function? Cosine, right? And when you write the outside function, everywhere you have a parenthesis, you are going to leave the inside unchanged. So what am I going to, it's going to be the cosine of what? X cubed, that's correct. There you go. There's the derivative. A lot easier, isn't it? Okay. Mm-hmm. Of a composition function, yeah. Any composition function. We can do probably half a dozen examples now because they go fast. Are you guys ready? So let's do it.
Separate quizzes on like U substitution.
No, isn't that awesome? Yes. I am not going to quiz you on whether you know U substitution. When you do the chain rule on either quiz, both quizzes that you have on chain rule, you can use this. As long as you know it, and the only way you're really going to know is make sure you do a whole bunch of them, okay? The U substitution is simply for understanding, so that you can understand that it does work, okay? Kind of like with trig functions, I didn't make you write out the limit and do the proof, right? If you did, I'm sorry, you didn't have to do that. All I needed to know for sine was that the derivative was cosine. But if you started, I don't know if you guys know Jesse. Yeah. Jesse, he would start doing the proof, and I had to tell him, I said, Jesse, you don't have to do the proof, just give me the derivative. I only made y'all do the proof that one quiz with the limit definition of the derivative because that lesson was on the limit definition of the derivative. Okay, that's why I made you do that. All right, so let's go ahead and do a few more. Let's do half a dozen if we can. Let's do another trig one. Let's say y is equal to cosine of 2x. See if you can figure out the derivative of that. Cosine of 2x. Is it a chain rule problem, first of all? I'm not going to solve it right now. I just want to know, is it a chain rule problem? Sure is. Yep.
Wow. It makes sense now.
If where you would normally see just an x, if you see more than just x, probably a chain rule problem. It is, isn't it? Yep. Inside prime, outside prime with inside unchanged.
So derivative is going to be the negative sign.
Of the outside, yes.
Yeah, negative sign x cubed.
Wait, are we looking at this one?
Oh, no, I wasn't.
Okay, all right.
All right, never mind.
All right. All right, folks. What did you get for this?
Negative 2 sine 2x.
2. Same.
Yep. What's the derivative of the inside? 2. What's the derivative of the outside? Negative sine. And then we have to leave the inside unchanged, right? Yep. Pretty cool, huh?
Will we lose points if we don't distribute the 2?
Yeah, or the negative, like if I put 2 times negative sign.
Oh, no, that's fine. But you better have parentheses. I have had students in the past write this. You know what that looks like to me?
2 minus sign.
That looks like 2 minus sine of 2x. Okay, this is wrong. This is correct. Okay?
A medium hard one and then a hard one.
Yeah, sure. Yeah. Oh, yes. Yeah, there were always hard ones. All right. Well, let's do a medium hard one. And then we'll start to add stuff on. How about? This will be fun. It's not that bad. Secant of x squared. Secant of x squared. What's the derivative? Secant.
Yeah.
You know what the derivative of secant is now?
Or no, is it secant times tan?
Uh-huh. Secant tangent.
I didn't get the one. I hope I didn't. I'll be mad if I did. Secant times tan. Sure.
Yep.
Mm-hmm.
It's a little thing.
Psst.
I don't know what that means still.
Me neither.
SST.
I can't.
It's confusing.
All right, how about this? Just write secant, tangent every time. Secant, tangent. And then their cofunctions. What's the cofunction for secant? Cosecant. What's the cofunction for secant? And what's the cofunction for tangent? Cotangent. So the derivative of tangent, secant. Derivative of cotangent, cosecant, except has to be negative because all co-functions have negative derivatives. All right? Derivative of cosecant, cosecant cotangent, but it's negative. Derivative of secant, secant tangent.
I don't get it still.
It's all right. Just memorize it.
He's like, you're just
No, it's fine. You just,
out of luck this
yeah.
time.
Some things, I don't know if y'all ever, did I already tell my story about the 3D posters? So there's these, back in the 90s, there was this very popular thing. You'd see a poster on the wall, but it was nothing. It was just a pattern, a weird pattern. You say, oh, that's a nice pattern, nice poster. No, not glasses. Those are from the 80s.
Oh, the ones that look like stick out.
These are the ones, right. You have to relax your eyes, and you have to almost cross your eyes in a way and just sort of like focus past it. And then eventually this image pops out. And everybody in the world could do them except me. And then finally I figured it out. And once I finally figured it out, once you sometimes, yes, I like that. Eureka! That's going to be my new word. I like that. Thanks, Dorothy. It's a eureka moment. Eureka! Now I know. Now I'm on the inside. I've crossed the river. Okay? All right. Yeah.
What happened?
She said eureka, and I was like, oh, that's my word. That's the word I've been looking for. Eureka. Yeah. Okay. So the derivative of the inside is 2x, right? What's the derivative of the outside? Tangent secant or secant tangent, it doesn't matter, okay? Secant tangent, right? But what are you going to put inside of secant? X squared. And what are you going to put inside of tangent? Yeah, see, you must, if in doing the derivative, the inside winds up splitting into multiple parts, every single one of those parts gets the inside. Okay. All right, now a hard one. All right, let's see here. Okay. Oh, this will be a good one.
Hand is slipping off my pencil. Hand is slipping off my pencil.
There we go.
I hate when I do this. It is your fault.
I think that one's kind of hard.
It's hard.
Inside. What's on
The first thing you should do is convert it into a polynomial. You want to get rid of that radical.
So it would just be
X.
No?
no.
Parenthesis, x squared plus sine of x to the 1/2 power.
You put that to the 1/2 power, won't you? I'm not going to say it. I'm not going to make assumptions. I'm not sure.
Just look at this and do the derivative of the inside and the derivative of the outside.
It doesn't turn into a fraction.
It will turn into a fraction. Yep.
It doesn't look like there is an outside.
There is an outside. It's 1/2. It's something to the 1/2 power. So the outside goes like this.
I didn't even know that was possible.
Yeah. Yeah, you take the exponent, multiply it by the coefficient. Right, yeah. Yeah.
You have any connection here?
Well, he had a eureka moment. What's the derivative of the inside? Let's get that out of the way. Yeah. Now, watch this. It is very, very important because we are about to multiply this by something. So what do I have to do? I need parentheses because I'm about to multiply this by something. I'm multiplying the whole derivative of the inside, not just cosine of x. If you forget the parentheses, it'll cost you points. So derivative of the inside is 2x plus cosine times the derivative of the outside. Well, the outside function here is this blob to the 1/2 power. And if I wanted to do the derivative of something to the 1/2 power, I would move the 1/2 to the front, right? Multiply by 1/2 times x squared plus sine of x, inside unchanged, and then subtract 1. 1/2 minus 1 is negative 1/2. Negative 1/2 means that it's got to go to the denominator in the fraction. What fraction? 1/2. So it's got to be 1/2 times x squared plus sine of x to the positive 1/2 power.
And then that turns into
You know, like when your mind's too blown, like you forget
Sorry.
to write stuff down. That's what
Wait, how did I lose you?
You just lost me
lost
when
me
you
at
started
the
multiplying stuff.
when you move the 1/2,
I'm
that's,
really
that's pretty low.
Okay, all right, hang on. Would you agree that x squared plus sine of x to the negative 1/2 power, would you agree that this is equal to 1 over x squared plus sine of x to the positive 1/2 power?
Yes, but why would you make it?
Okay, I don't think I made it negative. Yes, watch this. Now, if this is equal to this, it's being multiplied by 1/2.
See, this is what math.
Because of the 1/2 here. Part of the derivative. We took the 1/2 and multiplied by the coefficient of 1.
Use the power rule.
Yeah, power rule.
Are you trying to lower
This times this, subtract 1. Right?
I think he's trying to do me.
All right, so what is 1/2 times this? Are we okay now?
Get out.
Yes.
Yeah. And now it's, look, 1 times 1 is 1. 2 times that is 2 times. Do you know where this 1/2 came from?
Yes. Power rule.
Okay, so I'm multiplying this times this. This is equal to this, and 1/2 times this is now multiplying two fractions. So multiply straight across. 1 times 1 is 1. 2 times this is, by the way, this is the equivalent of the square root of x squared plus sine of x. So square root x squared plus sine of x.
Wait, can we have a radical at the bottom?
Oh, absolutely. I told you at the beginning of the school year. You might have forgotten. But yeah, in calculus, we're okay with radicals on the bottom. Now, this is now being multiplied by 2x plus cosine of x.
I don't think we can do that.
Can't I just put that in the numerator?
No.
Yeah, because if I multiply this times 5, that's 5 over, right?
I'm literally not comfortable with anything you've done.
She sounds like a victim.
Okay. All right, let's go back. Dorothy, are you okay? Are you okay with the fact that the square root of x squared plus sine of x is equal to this?
This is too
Kind
much
of.
pressure.
I'm not fully committed to it. But kind of.
Are you okay with the fact that x to the 1/2 is equal to the square root of x?
Sure.
Eh.
Just
All right. It seems to me that your issue is converting radicals into
Yeah,
polynomials. Okay. And I understand that. I have been teaching that idea. This is my 6th year teaching that idea, and it is very clear to me. 6th. Yeah. And it is very clear to me that there are, like geometry, there are some people who are okay with it and some people that aren't okay with it. Do you know what an exponent is?
yes.
Do you know what it means?
he just got real.
No, I was being...
He just got real
No, you
basic.
guys.
I'm sorry. What I mean is, do you know what an exponent means? Can you say, like if I have 8, let's do something a little easier. If I do 4 to the 3rd power, okay? Do you know, can you make a sentence statement, not that tells you how to get the answer, but that explains what this means? That is a sentence explanation that would give you the answer. Okay, that's describing what you see. Do you know? Let me tell you how to say this. Ready? Here we go. Ready?
If this is longer than
Say that again.
How many times you multiply the base times itself?
Correct. That's one way that's what most people who could give an answer would probably give that answer. But consider this.
makes sense.
What this means is, in a product, include the base of this many times.
Yeah,
Well, that works.
I like his.
Okay?
Yeah, his-
Well, sure, that's because, but here's the thing. His is still on the borderline of getting the answer. Okay? So, if I say x to the 373 times, I would ask you how many factors there are of that. How many factors are there? There's actually 374 of them.
One.
That's correct. There are 374 factors. 373 of them are identical. The other one is 1.
I don't even. Oh, I get it.
Okay?
I guess.
So it makes, watch this. If I do x to the 7th times x to the 4th, okay? Do you know how many people will tell me that this is x to the 28th power?
Don't
Yes.
you add the powers?
Yes. And one way of understanding that is how many factors are there here? And how many I'm sorry, plus 1. Let's leave 1 out just for a minute. But you're right, yes. How many x factors are there here?
7.
And how many x factors are there here?
4.
And since it's multiplication, how many overall x factors do we have? 11. That's x to the 11th power. Right? Yes, ma'am. Huh? A factor is a unit in multiplication. Okay? An addend is a unit in addition. So if I do 4 plus 7 plus 9, I have 3 addends. 4 is an addend, 7 is an addend, and 9 is an addend. Okay? In subtraction, I can't remember the words in subtraction. I know one of them is subtrahend. I can't remember what the other one is. Okay? In division, you have a dividend and a divisor. The answer is a quotient. In multiplication, you have factors and a product. Okay? So, a product is a combination, is an operation through multiplication. The things that you multiply are called factors. Okay? So, in this particular case, if I have x to the 1/2, or let's say 49 to the 1/2 power, how many times should 49 be included?
1/2.
1/2 times as a factor. What is 1/2 of 49 through multiplication? 7.
Oh, okay. Got it.
Yes, if you were to split 49 up into 2 factors, 1/2 of them are the answer. Does that make sense?
1/2 of them are
Okay? Yes. If you do, let's say, okay, so 4 to the 3rd power equals 64, which means 4 times 4 times 4 times 4, correct? Now, if I want the cubed root of 64, that's the same thing as 64 to the 1/3 power. That's 4 times 4 times 4, and I only want 1/3 of those factors, which is 4. Does that make sense, Randy?
I knew what it meant.
I don't even know how.
Right, yeah.
I get what you were saying.
Turn around and ask them if they get it.
Yeah, see, my explanation now can be used to understand fractional exponents. That's why for this time, I preferred my definition over yours. Your definition, perfect.
Do what, Jasmine?
Yes, sir.
Still on this topic.
Yes.
How would you solve say it was 64 to the 2/3?
Okay, 64 to the 2/3 power, okay, exponents can be, if I have x to the 11th power, isn't that the same thing as x to the 7th times x to the 4th?
Yes.
Right?
Yeah.
So, can't I split 2/3 up into 2 and 1/3? Oh, I'm sorry, I did this wrong. Sorry. If I have x to the 12th power, isn't that the same thing as x to the 3rd power to the 4th power? This is 4x to the 3rds. How many x's are there here? 12. Well, just in this one, 3. And then I'm taking 3 x's and I'm doing that 4 times. So 3 x's, 3 x's, 3 x's, and 3 x's. How many x's total? 12. So when you take something like this and raise the whole thing to the 4th power, that's when you multiply the exponents. So can I not take 64 to the 2/3 power and make that 64 to the 1/3 power squared?
Yes.
That makes it, that looks a lot better in my head.
Yeah. Another way of thinking about it is I want 2/3 of all those factors.
Wait, what was
16. 16.
All right.
And another way of thinking about that is I want 1/3 of them, and then whatever that 1/3 is, square it.
Wow.
Crazy.
Mind Behind.
Yeah, if you want to go even further, you can actually square 64 and then do the cube root of it.
This is gonna get.
Because 64 squared to the 1/3 power is still 64 to the 2/3. Why does that work? Because it's multiplication and division. Multiplication and division are far easier to deal with than addition and subtraction. A lot easier to deal with than addition and subtraction. Yes, sir?
Isn't that the same thing as having 3 outside the square root of like 64 squared? Right? Is the 3 outside of the square root?
Oh, yeah, yeah. This would be the same thing as this. Yep. Yeah. All right. It's good stuff. Really good stuff. Okay. All right. So now back to this. Now, the hard question that you asked for. We convert this into this to the 1/2 power. Now we just do the power rule on it. 1/2 times the coefficient is 1/2 of this. Reduce that by 1. 1/2 minus 1 is negative 1/2. A negative exponent means this whole thing goes into the denominator. Okay? But we are still multiplying this whole thing times the derivative of the inside. Okay? What is 2 times 1/3? 2/3. We take the thing we're multiplying by and multiply it by the numerator. So if we're multiplying this times the this, we can multiply it by the numerator, and it just becomes 2x plus cosine of x over 2 square root of x squared plus sine of x.
Where do you put things?
That, yeah.
Are you ever
Where do
gonna
you
put
put
something like that on the quiz?
Probably not. I don't think I'd put something like that on a quiz. They wouldn't even put something like that on the AP exam. That's too complicated. It would. Oh, wait, hang on. Wait. Let me look at it again.
Yeah, they would. What? Yeah, they would.
Yeah, you know why they would? No, let me explain why they would. Look.
Because it challenges you.
No, because it actually doesn't take as long as you think it does. A person skilled, a person who knows their math. Okay, no, not just me. There are lots of people out there lots of people out there. The first thing they would do is they would turn this into that. That would take them about 5 or 6 seconds, and then they would say, well, I know I need the derivative of... First of all, they are going to suspect there's a fraction, because as soon as they see a 1/2 power, they know that that's going to go to what? It's going to go to negative 1/2 when they take the power rule, right? So they already suspect that there's going to be a fraction, okay? So in their minds, they're probably already thinking fraction.
Where do you put the you said you put the inside
what are the
outside?
inside
Where
and
do you
outside?
put that in the final answer?
The inside, okay, again, we're going to go back to, without doing any shenanigans, we're just going to do it the way we see this. The derivative of the inside, 2x plus cosine of x, right?
Yeah.
Times the derivative of the outside, which is multiply this times the lead coefficient, which is 1/2, times inside unchanged. Oh, I didn't put an x there. Okay? Reduce the power by 1, negative 1/2.
Oh, so the inside's already in there.
Yeah, the inside's already there. And now, a person who sees this negative, they know that this is going down to the denominator. At this point, they're going to stop writing, and they're going to start looking for their answer. They're going to look for an answer that has the square root that has 2 square root of x squared plus sine of x in the denominator, and then they're going to find the answer that has 2x plus cosine of x in the numerator. So, let's do at least one more before we pack up. Okay. All right. Well, they asked me for a hard one. Let's do one that you're more likely to see. You want to see something you are more likely to see on the AP exam? Okay. X squared cotangent of 3x. Think about what you're looking at and then do it. Huh? Be careful with this one. This may actually be harder than the last one in terms of procedure. Let me ask you this, Dorothy. What is it that you're looking at? A product. You are looking at a product.
Oh yeah, I'm not telling you to do this.
Oh, sorry. Yeah. Yeah, if you're good with this one, you got to be careful and know when you're looking at a product or a quotient. This is a product rule problem with a chain rule, with the need for the chain rule.
Is the inside 3x still?
Uh-huh.
All right.
Yep.
So
No, it doesn't. Just walk through the product rule.
all right. Let's start.
How do you start the product rule?
Wait, isn't it 0?
The derivative of, yeah, this.
Okay, which is? What's the derivative of this? 2x times cotangent of 3x. Okay, we're halfway done. Plus this, x squared. And what's the derivative of that? Now we got to do the chain rule. What's that? Well, that would be the derivative of the outside. Yes, but don't forget to do the whole chain rule on this. Derivative of the inside.
So negative cosecant 3.
Well, yeah, but everybody's running to the derivative of the outside. Can we not forget to do the derivative of the inside? 3 times
Oh man.
negative cosecant squared of 3x.
Wow.
Oh wait, missed a parenthesis. There we go.
Is that the answer?
Yeah, and this is one way to write it. There's other ways to write it. You could distribute the negative out here, put it there. You could combine the 3 and the x squared. So then you'd have minus 3x squared cosecant squared of 3x. And then...
Please make sure you read your email from you that just sent. Check your email. Thank you.
Yeah, RCA, you guys can go. Yeah, you have a question?
Your book's right here.
Oh, thank you.
Before the x. I'm about to cry.
We're taking this test on Friday, correct?
No, Wednesday you'll have your first chain rule. I mean, I'm probably going to make the one this Wednesday easier than the one that you take on
So Friday.
Friday.
So Friday's going to be a harder version of the one we take on Wednesday.
Probably. And, I have to, darn it, they left. I have something to hand you guys. You can actually get it online. That too, yeah. All right, I'm giving you a worksheet. And I wanted to go over some of these, but we'll probably go over some of these on Wednesday since we can't go over any of them right now. Everybody take one of these. And I want you to try and figure it out. The key, the answers to this are posted on my website. Okay? So, now the quiz, let me go shut this off first.